Well, Mark, thanks for joining us today. Excited to have you here. This is a huge honor for me. Microsoft MVP, 43 books now. Today we're going to sit down and talk about Windows clustering.
Yeah.
And so, you know what, this is something that IT pros have been hearing about for decades at this point in time.
And avoiding assiduously for nearly 20 years.
Yeah, I'd say so. So you're telling me that you're going to simplify this for us now in the next hour or two, right?
Here's really where it comes from, is that it first comes out, I'll be talking about this in the talk, but really, it originated in something called Wolfpack. When a beta name is more interesting than the product, that's never a good sign. This is back in '98. Digital is working with Microsoft, and Digital is famous for their clusters. They've got these VMS mini computers, VAX mini computers running with a VMS, and they had some kind of cluster system that was reasonably priced, very, very reliable. Ticketron, to this day, I'm told, is using these things. You can't buy the boards anymore. They've got baling wire and spit to put these things together. And Digital was in a partnership with Microsoft and gave them a bunch of this. Because back in '98, they were involved with Digital because Digital were the guys who knew how to sell to enterprises. Microsoft didn't know how to do that. How things have changed. So they gave them a lot of the technology. And Microsoft adapted it to NT4 Enterprise Edition. And so it was known as Wolfpack. And I got a chance to play with it. I was lucky enough to get a chance to play with it back in '98. And I walked away saying, this is really hard to set up. It's not that terribly useful. The products you need to support it are horrendously expensive. I hope it works out for them. And really, in 2003, much of the same story, 2004, but something happened. 2008 server really turned things around and made it more reasonable. 2008 R2, bam, spike between the eyes. Something very, very important. It enabled Hyper-V to be as good as VMware when it came to clustering. 2012, another hit to the jaw, makes everything dirt cheap. All my complaints about it. But the problem is, I've been writing Windows Server books since, the late Stone Age, and I've never covered clusters. No one's ever complained because, when I'm a tech ed and I'm talking to 1,000 people, I say, how many of you run in Windows Failover clusters? And is it crickets? Maybe I'll get 15 people who set one up. But 2012 changed all that. And the problem is that all of my readers and me were standing around with our pants around our ankles saying, we got to know this cluster stuff. I had to learn it. I'd been doing it on and off, but I had to learn it when 08R2 came out because it was a cool Hyper-V feature. And when 2012 made it cheap, there was no question about it. So this is like a mission. I get a mission now and then. My latest mission is I want cluster to be super easy. I've done this talk around the world. It's often extremely highly rated. By the way, the one I do around the world, that's the short playing AM version. We're going to do the long playing FM version. And it's going to be fun because not only are we going to do the basic concepts, we're going to have time for these brief deep dives. Just brief ones. We can snorkel. We don't need scuba for them. And everybody at the end of this, if you've got two machines lying around, I had a ThinkPad T61P and an old compact DL-4 or something server. I set this up the first time, and I got it working just like that. So I'm hoping everybody who's watching this will take this time, add this to your skill set, add this to the things that you know about. So,
awesome.
All right?
So let's start off with, in its simplest form, what is a Windows cluster, and why would we want to use it?
I'm glad you asked that question. Let's look at these. So our topics today are going to be, why indeed cluster? You've asked exactly the right question at the right time, as is always the case. And then we'll find out that there's a basic problem with clustering. Is that on the one hand, the stuff we want to do, it is almost impossible. So there's little compromises and some extra checks we have to do. Then we're going to make sure that so that this isn't horribly just a lot of concepts thrown at you, we're going to jump right in and start building a cluster. And that'll give me a chance to stop and then fill in with concepts along the way. And the first thing we're going to do, we're going to set up the nodes. Those are the servers. We'll have pictures soon.
Okay.
After that, shared storage is a really, really important concept. By the way, on this page, I'm using lots of phrases here that don't make any sense yet, so trust me, we'll define them all, okay? Then it's assembly time. Once we've got the shared storage and the nodes, which are the servers, then we can run a little wizard, if we're that kind of people, or one line of PowerShell, if we're those kinds of people, and we'll get that cluster built. Still can't do anything, but the superstructure's in place at this point. After that, we have to go back to the prime directive. We have to fight corruption. It must be rooted out. Well, you're from Chicago, so I don't know if that's as big a deal for you, but still, we have to fight corruption. And we do that with something called the quorum, the heartbeat, and the witness. Unless, of course, we get rid of the witnesses, in which case there is no problem with, anyway. So, and then we're going to see how they challenge VMware. That was the big thing that occurred in 08 R2. And, of course, when the cheaper stuff came a little later. And then finally, we'll be ready to drop some things on it. So along those lines, why cluster? Why now? So clusters bring reliability. The whole problem that we're typically looking at is that, let's say we've got, you're my boss and we've got a SQL database that can never be down. We've got a Hyper-V cluster, and boy, we can't have that thing down. Even in some of the earliest days, not many people did this, but some folks were so reliant on Microsoft DHCP clusters that they got clusters so that they could cluster a DHCP scope. Because if you think about it, the DHCP RFC never said it's okay to have two servers on this. Everybody does the 80-20 thing, but you're not supposed to do that. So Microsoft included DHCP as one of the offerings. So here we've got a scope that can't go down. So we have 2 or 3 servers serving it at the same time. Or maybe a pile of files. The very, very first kind of cluster was a file server. The idea was I had 200, 300 files, and I had to be sure that if one of the file servers went down, another one could step in for it. So it's got to be up. Now, what did we do in 2002? In 2002, we would go out and buy the big, expensive, gold-plated 3 power supplies, and somebody vacuums it out every week.
The memory that they promised would never fail.
Never fail, exactly. And extra electricity and guys up on the roof shooting squirrels because the second most common cause of power outages is squirrels getting into the wiring, because rodents, their teeth grow their entire lives and they need something to chew on. So they chew on these things, and when they get to a certain point, they become part of the circuit briefly, and after that, the power is out. So we got that kind of level. That's how SWAT. We got SWAT squirrel teams, all right? But that doesn't work so well. The great thing about clusters is this: if you think about it, how do we make teams more effective? We get a couple of people watching each other. We have 2 normal people working together can be a lot more productive than one very, 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 very smart person. So we have a bunch of commodity quality systems, and they watch each other. I'll be more specific about that. And that's basically how clusters work. The idea is, instead of trying to find the perfect machine or the perfect person, you get a bunch of people, and they're all watching each other, and the net effect is that's behind the curtain. If I'm the user, I don't know that if one of them's dead, the other one's picking up for it. Make sense?
Yep.
To that end, I believe that I can explain this with a metaphor: accounting. Now, so the question is, do you trust your accountants?
For the most part, yeah.
Yeah, everybody says that, but you don't. And I can prove it. So imagine, first of all, most accountants are trustworthy.
Right.
So here on that slide, I've got, let's say that 90% of accountants are honest. Now, important footnote, if there are any accountants in the audience, I just needed an easy number that I could do some mathematics with, okay? I don't want accountant ninjas coming after me. It's like, have you seen your accountant ninjas? No, because when you do, that means you're dead. So let's say 90% of them, okay? So that means you guys, get your accountants in, your bookkeepers, and are they going to rob you? Well, you got a 9 out of 10 chance that they're not going to. We would call that 90% uptime. And that's, now we're doing the nines thing, right? Mm-hmm. What are good nines that you hear?
Well, the whole Six Sigma, eventually you want to get
I don't know how you do 6, because 5 nines means you only have 5 minutes of downtime all year. 6 nines would be like, I'm guessing.
It's the holy grail that we all seek for.
It's exactly right. And yet things go on when we're down for a few minutes. But 1 nines, that's not good. You're not going to hire me as if Pluralsight needs a new IT director, you're like, let's get Manasseh.
Not at 30 days of downtime a year.
It's like, Gareth, I'll tell you, man, we will definitely have you 90% uptime. That's fantastic. That's not going to work. And so what we do instead is that means there's a 90% chance of success, or we call it 90% uptime. All right. Now, the question, do you trust your accountants? That's not true. We get some more accountants to check out the first set of accountants. We call them auditors, but we still don't trust them. So let's just say that those auditors, they check the first ones. Now, if 90% of the auditors, because they're just accountants, are honest, so what do we have? The chances we have a 10% failure. We want the auditors to find the failure. If 90% of the second set, the auditors, are good, then they're going to find 90% of the 10%. So what used to be 10% failure becomes 1% failure, right? Mm-hmm. And as a result, we have a new expected success rate of not 90%, but 99%. That's a big improvement, right? Okay. Mm-hmm. What could we keep doing? If we wanted to, we could add a bunch of accountants, and that 1% that's still a failure, well, that then becomes 0.1.
At that point in time, it just becomes a cost-benefit analysis, basically.
Exactly. And you see how cool it is? We're buying commodity-level stuff you get from HP or Dell or IBM or something like that. And you can add as many as you like, and you just dial up the amount of reliability that you feel like. So here's where the pieces come in, though, and I think this is really important, that if you get this slide, then you get everything, okay? Is that, let's say, for example, that it's 1999 or 2002, and you're my boss, and you say, Mark, I heard we have this cluster stuff, and it's going to be really reliable. We're going to get some really good, go look into it. We want a really secure file server. Because if I recall right, the first clusters only did file servers. And for a while there in 2002, 2003, the single largest use of clusters, I am told, was print servers. Because a print server is basically a file server. Yeah. And if you ever had, like some companies will have these monster machines and like 100 print queues off of them. So when the machine goes belly up, you just dump the print queues from 100 machines, which is probably, it's just a mess. And so apparently that was the big use in 2003. Big meaning 15 customers, but still.
I was going to say, that must be some expensive printers if they're going to be buying the extra hardware.
It's not so much that. It's that the classic spooler problem for the longest time is that when you dump a driver, drivers are weird. Print drivers are weird because the spooler is a process by itself, and print drivers are these things that attach to it. That's what you'd see if I had a box. The box here would be, here is the Windows subsystem, here is the spooler, here are the drivers. That's not really what happens. The drivers aren't attached. They're like tapeworms. They live inside the spooler. It's like, they never leave. They never leave mom, They're living inside mom. And one of them dies. It just poisons everybody. The whole thing craps out. That was fixed in R2, in 2008 R2, if you flip some switches. But the problem was, seriously what happened? Big law offices or things like that, and they would have to, I guess it made sense for them, Anyway, so I'd start off by saying, boss, we went out and found a really, really good file server. This is 2001, and we think it supports a gigabyte of RAM or something really exciting like that, and big SCSI drives, and it's going to be $30,000, $30,000. You say, okay, Mark. Well, what else do we need? I say we need another server exactly like it, boss. A second server. What's that for? And I say, what does it do? It does nothing.
Yeah, you want this money for what reason then?
See, here's the thing. Its job is it just kind of sits there and goes, waiting for the first one to die.
Okay.
But think of what it'll do for the heating bill. It'll lower the heating bill, boss. You see, the one that's doing that work, HV1, that guy's called the active node. The other guy's called the passive node. He just waits. Oh, you want to hear what else we got?
I'd like to.
Got to go buy this thing called shared storage, boss. It's this thing called a SAN. And I guess we'd have to go forward in time to like 2003 or 2004 for us to talk about this. But, oh boy, that SAN thing makes those servers look really cheap. And we have to learn about this thing called fiber channel. And I've updated my resume, as it turns out. So we've already spent some money. Now, how does this all fit together? Well, okay. In terms of how clusters work, is that you've got one or more servers, and they're identical servers, and they all do whatever it is you're trying to cluster. If you're trying to cluster DHCP, they're DHCP servers. If you're trying to cluster file servers, they are identical file servers. If you're trying to cluster SQL, they're going to be SQL servers, running the exact same version of SQL, the exact same version of Windows, stuff like that. As identical as we can make these guys. Because if you really, for example, if you have CPUs that are different, in the slightest, you have to flip a switch, which makes both of them into Pentium 4 processors, which is just really nasty. So identical stuff. Then your shared storage. That's where we store the important data. So for example, HV1 and HV2 is a DHCP server. Can we store the scopes there? No, we can't, because if HV1 goes down and it's holding the scopes, then HV2 can't get to them. Same thing. If it's a Hyper-V, what are we storing?
Your virtual drives.
Exactly, the VHDs, the VHDXs. If it's a SQL server, we got the MDFs, the LDFs, all that kind of stuff. So it's an N plus first. Here I've shown you 2 nodes, but with Hyper-V you can have up to 64 Hyper-V servers, all clustered around that same shared storage. So some pretty interesting stuff there. Which leads to the whole thing, shared storage. Now that's an important phrase. Shared storage, we'll talk more about this, but shared storage means that's like an external hard drive that both of these machines talk to at the same time, but at the hardware level. And that's going to be important because it's important, spoiler, because...
Cause some problems.
Well, here's the thing. Because both of these are talking, you're 100% right, both of these are talking to this central storage thing at the sector level, low-level hardware level. What happens if you and I are scribbling on the same page at the same location? You know, we've both lost our data, we've scribbled all over each other. Bad stuff could happen then. Only one of the nodes does all the work, and that's called that's the active node. The others are called passive. Now that's the story until 08R2. 08R2 breaks through that barrier, and with 08R2, we're going to have HV1 and HV2 both getting some work done. Make sense?
Yep.
All right then, good. Which leads to the question, why are we talking clusters? Now, we kind of talked about this just briefly. Originally, clusters were expensive, hard to set up, and limited in failover speed. If one of those guys went down, you're pulling off a file server, it automatically fails over, usually under 60 seconds. Now, people are going to notice that their file shares are gone, but it's gotten much better. And as we're going to see SMB3, which introduces in Server 2012, that reduces that failover time to 0, which is awesome, cool stuff. Post 2003, so 2003 was troublesome also, but later on, 2008 made setup easier. It used to be that you kind of plug everything in and kind of hope it worked. This came with a wizard that would say, let's just double check before you turn stuff on, or while you still have time to send the hardware back. And then made all the nodes useful in 2008 R2 and made it cheaper in 2012. So they have been lame, expensive, and not good, but nowadays they're just so simple, everybody should be knowing about them.
And are you also seeing that shift because now we're, 3 years out since the 2012 revision, people are starting to be forced to either migrate or finally migrating?
Well, honestly, that's a great sidebar. Let's talk about that. So if we're looking at 2003, 2002, Bill Gates looks over at VMware and says, look at those guys. They're making like 2% of what we make. That's money we could have. He then said, we got to do something about this. This is abstract. I can't say that this is all entirely accurate. They said, let's go build it or buy it. So they bought Connectix, which became Virtual PC. And this was just, it's one of those Microsoft things where they just throw stuff against the wall until something works. The original Virtual PC was laughable. I mean, seriously. But they finally get Hyper-V going. And finally, they've got something that isn't ridiculous. But they got a problem with the whole clustering thing. And VMware, meanwhile, because part of it is that it's based on NTFS. They want to do this clustering stuff. NTFS is a general purpose file system that does everything. VMware guys, they don't have to worry about that. They're building VMFS. Its only job is to hold on to virtual machines. And they own the operating system. It's a variation on some kind of Unix. And so they can make something slick, lean, mean, and totally awesome cool. Microsoft wants to catch up. How are they going to do it? The way they always do it. They're going to offer something that's in the same ballpark, but a whole hell of a lot cheaper. Server 2012 was nothing more than a finely designed guided missile pointed straight at Palo Alto. If you look at all the things that are in there, and that's where the cheap comes in. That's why they made it cheap. But there's a problem we don't have to worry about, which is kind of chapter 2 here. I know you pluralsight guys like chapters. I just got to go on for a while, but I realize that we need station breaks now and then. I call it the dark side versus the prime directive. I got to change that. Cluster yin and yang. So let's talk about SANs and shared storage, and I've used the phrase shared storage. Now, basically it means data stored on a device that is, first of all, separate from all the nodes. So if I have 2 nodes, I'm not going to have the data on there, as I said before. And sorry to repeat these things, but if we walk away for 15 minutes, come back, I just find it helps to remember that. It's often a storage area network. Now, SANs, I'll arbitrarily put a line in the sand and say 2004. 2004 was the year of the SAN. The iSCSI standards come out at that point. They're still horrendously expensive. But at least instead of everyone have their own proprietary stuff, everybody starts to focus around something called iSCSI. Okay, good stuff. Now, what iSCSI does for us is that if you and I are both Hyper-V servers or SQL servers, we both see this drive, and we think it's an actual physical drive stuck in our chassis, but it's not. And you and I can write to it at the same time, and at high speed, because it is block level, hardware level, typically faster than trying to read and write files, because there's no file system overhead. It's important stuff, you know. Yep. So let's back up, and I don't know that everyone watching has done SAN stuff. So permit me, let's just do a couple of these. So what's a SAN? So the whole idea is, if you recall, when we were building data centers back in 2000 or whatever, we'd figured out racks. You know, that was around 96, around 97 that we figured out racks.
Hope so.
But 99 and 2000 and 2001, I would go to work somewhere. I'd do a class or something or consulting. And someone would always grab me and say, hey, if you want, I could get you into our data center. And what I want to say is it a big room with raised floors, a lot of air conditioning, and racks with blinky lights? Never seen one before, but you can't say that. So what you ended up seeing was I was in a place in Northern California where, they had just racks and racks and racks and racks of machines. And this is 2000. And if you remember in 2000, what did we think about Windows servers? Now, if I were to say to you as a smart Windows guy, here's my question. Okay, smart Windows guy. I'm going to do SQL and Exchange. Can I do that on the same computer?
In 2000?
Yeah.
If you did, you were in trouble.
Well, why?
Just the in-ops of both of those.
Okay, but you didn't say what most people said then, was they thought Windows couldn't handle it. There was a very strong feeling, Unix can do that, Windows is good for one workload. That wasn't true. But as you said, it was the carbon unit part, right? Where maybe the Exchange team, if you have to, because in 2000, how do it fix things? The most effective, Microsoft repair tool is a reinstallation disk, right?
I was like reboot and
exactly. Precisely, exactly. But if we're going to rebuild, we don't re-image SQL servers. We don't re-image Exchange server. We'd have to be building it. We'd have to get the SQL guys into the room at the same time as the Exchange guys. So what were we doing? We had racks and racks and racks of machines running at 5% capacity, which was great. So virtualization saved us. We didn't need as many machines. But we didn't fix storage. You still had a situation where your 1U server was sitting under your 4U box that had your SCSI drives in it. And if that SCSI drive went bluey, that server went bluey. So the question was, let's do something virtualized like it. So the notion was, we would get a whole bunch of drives, and you'll notice these are bluish. I'm going matrix here, okay? So these are the actual drives. We're going to move to red drives. This is a high-quality animation. I just want you to know that this is, that I'm terrible at animation, so this is the product of weeks of work. Anyway, we take a bunch of actual disks and we stick it in a box somewhere. It's got some kind of motherboard on it and it runs some kind of operating system, not Windows because they'd have to pay a license for it. And it's like it's one big imaginary drive. We then get some kind of interface. If you're my storage guy, then maybe it's a web interface, maybe it's, some kind of Linuxy stuff or something like that. And if someone in a project says, I need a drive, well, you can carve these things up into imaginary drives. These things behave, as far as the server's concerned, it's like you went out to Best Buy and you bought a new SCSI drive and you popped it into your server. You notice the red ones, because the blue ones over there, that's the real ones, and the red ones are the Now, we don't call them matrix drives. They're called LUNs. The phrase that people use for it is LUN, right there. And then we attach them into the server, and yes, that clip art refers to some very, very old compact hardware, but that was the only free clip art that I could find for this particular slide. And so what's really happening is what? We're taking old SCSI commands, and we're not running them over SCSI cables anymore. We're wrapping them inside TCP/IP or the language of Fiber Channel or something like that. So this is great. So shared storage is some SAN-ish thing that lets two or more servers read and write simultaneously to the same sectors or file server clusters or something like that. And you see where that could go wrong. Is that if you and I scribble on the same sector inside of a SQL database, what did we just do?
We just overrode each other's data.
What did we destroy, though?
Oh, at the sector level,
No, I'm saying we wrote into the same sector of a SQL database. So what happened?
Oh, basically corrupted the entire database.
The entire database. But we didn't corrupt the entire volume, right? What if on a bad day, you and I are writing to the storage bitmap on the NTFS volume at the same time?
it's going to get a real bad day time to update the resume.
Exactly. We just wiped the whole volume. So this is the thing is that so this is the dark side. Is that two machines are going to write to the same spot, something's going to get corrupted. So the important thing is cluster software. No one thinks about this, no one cares, but the quiet hero in there is that it lets these nodes dance without stepping on each other's feet. That's a very important thing. If we can't make that work, we're in a whole lot of trouble. Now you noticed that with that previous slide there, it says shared storage, the dark side. I managed to work in a Star Wars reference. But in the next slide, we say the goal versus the prime directive. You see, if you can get a Star Wars and a Star Trek, especially the day after Leonard Nimoy left the building. So anyway, so I think of it as cluster yin and yang. Just to review, we want reliability, clusters give us reliability. Yep. We love that. But clusters can't live without shared storage. Uh-oh. And shared storage opens the possibility of corrupting all that data.
You fix one problem, create another.
A much bigger one. Completely different. Or, to rephrase, I really love the fact that you're reliable, but don't toast my data. And so what you're going to see is some of the stuff in clusters is the reliability stuff. It's making sure that if you're a node and I'm a node, we're working together, we're doing handoffs nice and cleanly, et cetera. But then the prime directives always said, hey, not so fast, boys. Let's just double check that nobody's stepping on anybody else. Okay?
Okay.
So that's our yin and yang. Good. And it's a constant tug of war. And as time goes on, we're going to see different tools about that. So, good so far?
Good so far.
All right, let's talk now. And I want to start off by talking about the steps.
Okay,
Please,
so for the sake of everyone following along with us, though.
Please.
In this case, we're actually going to use some slides. We're actually not going to go and configure this on a live server, and it's purely just because of the hardware we have in front of us today.
That's exactly right. That's exactly right. If you want to follow along, there's a few things you could do. One is, if you have a big computer and you're running VMware Workstation, yeah. They have a cool thing, because normally you can't do this. I mean, normally we spin up virtual machines and we try stuff out. Clearly you can't build a virtual machine to become a Hyper-V server. But you can. VMware Workstation has a thing, totally unsupported. But you can.
But it works.
As long as you're just demonstrating it.
Yes.
Yeah, I would be. Let's not put it to production.
No, this is for the home lab environment to follow
Exactly.
along.
So if you want to try that out, I've only done it once, but it does work. You got a big ass machine. You've got VMware Workstation on it. You can build Hyper-V box, and then a third box that runs some kind of SAN software. Could be just a file server, et cetera. Absolutely. Or do what I did. I had 2 cheap machines just lying around gathering dust. I put Server 2012 on them. My shared storage was just a file server, my 2003 file server that had some empty space on it. And so I was able to build all this stuff, really very easily. We have lots of screenshots here. The only reason we're not doing it live is we don't have the hardware here, and I'm trying to compress time as much as possible.
Perfect.
Okay, thank you. So the first thing is we set up the nodes, and the node, I'm going to expand on all of this, but the nodes are going to be the servers, the SQL servers, the Hyper-V servers, et cetera. We're going to create the shared storage. And this is the cool part. I forgot to mention this. Shared storage has always been expensive SANs until 2012. 2012 changed the game, and 2012 said, hey, here's a cheap kind of shared storage. So some very good news there. And if necessary, we're going to introduce the shared storage to the cluster. Sometimes it's automatic, sometimes we got to do it. Then we configure something called cluster quorum. Now we're back to the prime directive. This doesn't make the cluster faster. It just keeps the cluster from completely destroying all your data, which is never a bad thing. Optionally, if we want to have the higher performance cluster, the kind that Hyper-V starts looking as good as VMware's infrastructure, then we're going to add something called a cluster shared volume, which is actually, I think, I'm certain of this, is a preview of where NTFS is going. Because we already have a thing called REFS sitting in, certainly in 2012, R2, I think it was in 2012 as well. And the reason I'm having trouble recalling that is that you can't use it for anything. Microsoft says that's just experimental, don't do anything with it. But I think following is a speculation. It is not a violation of any NDA that I may have ever heard as an MVP, because I'm not a storage MVP. But I think it's reasonable to speculate that either in Server 2016 or the next one or whatever, because kind of the cool stuff we're going to see in cluster shared volume ends up being in REFS. We weren't going to talk about it, but while I'm here, let me give you one great example. Ever had a situation where you got a server and you run check disk, and there's some problem where it says, you're going to have to reboot for me to fix this, and you know that's going to be 12 hours. With cluster shared volumes and with REFS, you never have to take them offline.
Really?
Yeah, isn't that totally awesome? It's like, when can I make that my C drive on my laptop, right?
Absolutely.
So, then we'll add a role, and that's just techie for, we've got the cluster, but it doesn't protect anything yet. So we'll drop a virtual machine in there. So those are going to be our steps. All make sense?
Yep.
Good. So let's, other thing too, understand that all of my examples here, we could be talking about a SQL cluster, we could be talking about a file cluster. We're going to do Hyper-V and why? Because Hyper-V is the reason Microsoft did all this improvement. This is their vehicle. This is the bulldozer they're going to try to use to roll over.
Is it the most common use case that you see out there?
Is it the most common use case? There's an awful lot of SQL clusters out there. But SQL has an interesting perspective. SQL always goes their own way. They had a directory service before Windows did, so that was interesting. And SQL actually has something that I'm not going to talk about because I'm stupid about it, called Always On. And this is relatively recent versions of SQL Server, and I am told that you don't even need the big, expensive enterprise one to do it. So the SQL guys are doing their own cluster, and that's a great point, by the way. Cluster is a big word. I'm showing you one kind of cluster. It's called the Microsoft Failover cluster. Knowing about this is useful stuff, absolutely. There are other clusters out there. There's third-party tools. The VMware cluster tools that are in their infrastructure, great stuff. The things that SQL do. So this is just one of many. Perfect. Okay, so my examples are going to be Hyper-V. And again, the reason that they've expanded so many things, in 2003, if I remember correctly, you could have 4 nodes. That was it. If you're clustering SQL, 4 machines, they bumped that sucker from 4 to 64 in 2012. And for one reason and one reason only, Hyper-V. But the concepts will transfer cleanly over to other stuff as well. You won't have as big numbers. For example, the scale-out file server for application data has a maximum of either 4 or 8 nodes. And I don't know how many it does for SQL. So the idea is they made it cheap to try to take out VMware. So to set up the nodes, step 1, identical boxes. If anything's different at all, it'll give you heartburn. So that's really important.
So I think a good step here,
please.
What's a clear definition of a node? I mean, we hear the term node a lot in technology.
I know,
in this case,
it's so true.
What are you calling a node?
Okay, so a node is, if I'm going to build a Hyper-V cluster with 3 Hyper-V servers, those are nodes. Those are nodes. All they do is compute. Okay. They don't actually, other than the storage they need to run the operating system, they need almost no storage on them. Because again, the important data is where? It's sitting on the
shared storage.
Precisely. The SAN, or as we'll see, the short storage spaces, or a file share. So, okay, good. So we need 2 or more identical boxes. And we're going to put them on the same subnet usually, but there are certainly cases where you can have a cluster. And the reason we want them on the same subnet is we're talking back, if you and I are nodes, we're talking back and forth really quickly. Okay. There are ways to build what are called geoclusters, though, where you actually do have machines that are geographically located somewhere else. But in the main, we're not building those. In the main, we're talking about stuff in the same subnet. Okay. All right? So if we're going to build a Hyper-V cluster with 64 machines, I doubt we will, but if we were, those would be 64 machines on the same broadcast domain or something like that. We install a cluster-aware version of Windows Server. This was a big deal. When Wolfpack first came out, you had to get, they were changing around between Enterprise Edition and Advanced Edition, but in any case, it was the $4,000 version, not the $1,000 version. And that was significant because, an awful lot of people went to Enterprise only because they wanted X gigabytes of memory and they couldn't. So that's why it was great that Server 2012 changed all this. I may be wrong, but I don't think of the many SKUs of Server, I don't think that there's one left that doesn't support clustering. And it's not just clustering the operating system, it's clustering the application as well. So Windows is cluster aware, that's groovy. Right. But if you're going to stick on top of it the fax service, I'm making this up, if the fax service isn't cluster aware, then you can't cluster your fax service, which would be good because why are faxes still around? If you think about it, you ever get something where people actually send you it's a document, it's a contract. They'll send you the contract as a Microsoft Word document, and they want you to print it out and sign it. It's like, you know about attachments. Why can't I just? And I think it's a problem because who still uses faxes? I think that there are fax people, and they only meet other fax people via fax. And if we were to shut these fax servers down, then the fax people would go away in a generation, and we wouldn't have to talk about where was I. So, got assigned static addresses. They're servers anyway, so you're probably going to assign static addresses, although I get lazy about the IPv6 static addresses on my domain controllers. It still barks at me, though. So assign static addresses, join an AD domain.
Okay.
I've never found anything that says you have to be a domain member, but for the life of me, I can't see how you build a Microsoft failover cluster without your nodes being member servers.
Okay. Does the domain level or force level need to be at a certain version number? Because you're talking about the actual improvements that they've made since 2008, 2012,
That's a good question.
2002.
Not to my knowledge. If we're talking Hyper-V, let me think about this. If we're talking Hyper-V, I don't think we need a particular domain functional level or something like that. Certainly, I wouldn't want to touch anything under 08R2 domain functional level, but I could be wrong about that.
Okay.
Good question. Go back and look that up. Then check DNS 3 times because seriously, if anything gets even mildly wonky with DNS, you know the normal rule is the first rule of AD troubleshooting is it's probably DNS. And the second rule is if rule 1 doesn't apply, it probably DNS anyway. When it comes to clusters, though, oh my God, it's nightmarish. And by the way, no DCs. Domain controllers cannot be nodes. So we're talking about a number of machines at this point. If we were going to have a 3-node cluster, it's at least 3 member servers that are running Hyper-V or something. Certainly 1 domain controller. Nice to have 2. And an external box for a SAN.
Perfect.
Mm-hmm. And then we set up virtual networks. Set up networks in general, as a matter of fact. So as you're going to learn, we're going to have more than one. We could have one network and do all the comms on that network. But a lot of people are going to want to stuff their boxes full of NICs for, first of all, reliability's sake. Because you know, if one NIC goes bluey or a switch goes bluey, if there's an alternate path. What's cool about this too, is I don't have to teach you anything. Once you plug it in, then the failover cluster manager software goes, oh, there's like 5 ways to get there? Groovy. And it just picks the one that seems fastest. And if that goes away, it just goes to the next one, et cetera. So it's all plug and play. Then you may install extra network adapters.
Which if you're going for reliability, I mean, that seems to be a logical, inexpensive thing to incorporate.
Particularly when you consider, we're going to see that there's a thing called the heartbeat, where the nodes keep track of each other, whether they're alive or not. You could certainly do that with a 100 gigabit NIC without any trouble at all. I mean, you don't need much bandwidth and redundancy as well. And as I said, you need a cluster-aware version of what your application software is. So cluster-aware version of the operating system, cluster-aware version of the app. Okay. Then you have to install a feature, it's not a role, on the server called the Failover Cluster Manager. And just to show you what one of those looks like, and I can't read that little print, so let's get closer. And over to the left there, it says vmcluster1.apple-orchard.net. As you're going to see, clusters have a name of their own as if they're a machine. Okay. That was a spoiler. I kind of screwed that one. And then there's roles. Roles is what are we protecting? Nodes, again, what's that? That's the name of our servers, our print servers, our file servers. Actually, you can't cluster print servers anymore, but your file servers, your DHCP servers, your SQL servers, whatever. Storage, we're going to have disks and pools. Disks really means you're doing a SAN. Pools really means you're doing storage spaces, which we'll talk about in a minute. Okay. And then networks, you notice under that, I've got cluster network 1. Mm-hmm. If I had a bunch more NICs, I could define cluster network 2 and 3 and all that stuff. Perfect. So this is nice. It's for a GUI. Although it does have a few wonky things in there. If you look over to the right there, you'll see things. There's a summary of it that says 0 clustered roles and 2 nodes, what its name is. There's a current host server, what the thing it's running on at the moment. You're going to see we have 2 nodes called new and old, and something called quorum configuration is called node majority. That's not helpful here, but we're going to fix it. So, next cluster concept that's important is, so let's step back, and I want to have a different example here. Let's have a file server cluster. And so what do we got? Well, we got a file server, and we got a file server. And these guys are identical. And this is going to be old style, sometimes called active passive.
Okay.
Originally it was called shared nothing clustering, and then it became called active passive because shared nothing wasn't confusing enough. Okay? So we'd have a machine here, and its name is whack-whack-fs1, and it's got an IP address. And I got another machine over here, whack-whack-fs2, it's got an IP address. I love the whack stuff. You know, we used to say backslash to like 1998, and then the Microsoft guys, I was up there, and they're talking about DFS. This guy starts saying whack whack. I said, what's the whack?
Which character?
Yeah, exactly. Because you know, the Microsoft guys come up with a new word, and it just spreads through campus in 5 days. And if you haven't been to campus in 5 days, everyone's like, you don't know that? You're not connected. You didn't recharge. You got this. I said, wait. So a backslash is a whack? He says, yeah. I said, so if a backslash is a whack, is a forward slash a back whack? They hadn't thought of that. Anyway, so our file servers are whack whack FS1, whack whack FS2. Notice they have IP addresses.
Yep.
This is an important point to be made. If I want to get to this cluster, should I connect to FS1? Well, no, because it might die. Should I connect to FS2? No, because it might die. Cool thing with clusters is that we go, these aren't the servers you're looking for. Instead, there's a thing called whack whack cluster 1, some kind of name, and an IP address. Notice the IP address is different from either of those static addresses. So we've stolen a static address and given it to an imaginary concept, a cluster. We also get a name. It gets an AD machine account, which can be a nightmare once you break the cluster down because it just sits there saying, why is no one talking to me? And you get all kinds of errors in the event log. So, make sense?
Yep.
Yeah. So you connect to the whack whack cluster. You know, they don't connect to whack whack FS2 or whack whack FS1. All right, so that's good. That was kind of like our node, setting up the node, first step. Second step is we're going to talk about building the shared storage. In the old days, it was easy. Go spend $1 million on a SAN, and then connect the SAN. It was as simple as that. Now we got lots of options. So the shared storage, in a very abbreviated fashion, the shared storage, again, that's the place where we're putting the MDF and LDF files for SQL. It's the place where the VHD files go, where the scopes for DHCP go, et cetera, et cetera, et cetera. Okay? We have 3 options. Used to just be iSCSI LUNs from a SAN. But you can also do a thing called storage spaces, which if you've played around with Server 2012, you've heard of, but a lot of our listeners wouldn't have done that, so we'll talk very briefly about that. Or a regular old SMB file share. That's the awesome one. That's the totally, you've set up SANs, right? It's not that, you don't wake up one morning and say, hot damn, honey, I get to set up a SAN.
Well, and then you look at the costs. I mean, the cost is dramatically decreased as you go down the list.
You know what's interesting also is that ever since storage spaces came out, and I've been talking about it from the beginning, because I've always said that storage spaces, it's basically Microsoft SAN. It's got limited functionality. I say to people, it'll give you 70% or 60% of what a SAN does for 20% of the price. And everybody said, nah, it's a piece of crap, blah, 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 we're not going to use it, and sure enough, within the next year, SAN prices have been dropping. If nothing else, Microsoft has blessed us with a reason for the SAN vendors to start really dropping their prices. But you know, if you're a Microsoft shop, Storage Spaces has a lot of really positive stuff, as well as 2 amazingly cool features in Server 2016 that I can't talk about. But when we get to that point, that's I'm sure there'll be great pluralsight videos about that stuff. But the file share is just the neatest thing. The file share is the neatest thing because I'll tell you a quick story. So Server 2012 is coming out. And the Microsoft guys called me and they said, hey, you know, we're going to do a launch on September 4th. I said, yeah, worst kept secret in the world. They said, we're not going to do a physical rollout. We're just going to do a virtual one where we're going to have videos about different stuff. I said, oh, cool. Good luck. Hope that works. They said, no, we want you to do a video. I said, I get to do one of the videos? Really? You know who you're talking to? And they're like, yeah. I said, what would you like me to do? Networking or Active Directory? They said, no, we want you to talk about Hyper-V shared nothing live migration. And I said, is that because of the Hyper-V books I haven't written? Or is it the Hyper-V talks I haven't done? Maybe the Hyper-V columns I haven't written. They said, no, you're doing fine. So I dropped everything, set these machines up. I learned Hyper-V. I mean, I played with it before, you know, but 2012 had some extra cool stuff and that sort of thing. And then, so I was able to get everything working. Didn't need a cluster. So I came out to campus, and I'm there the day before or whatever. And I'm an early riser anyway, A, and B, I'm East Coast guy, so I'm up at 3 in the morning. I'm remote desktopping over to the lab over the garage and moving the virtual machines from one server to another, you know, not using the cluster. I said, you know what? I should build a cluster. So I had a file server with some space left on it, so I put the VHD over in that cluster. I rebuilt the thing, so I got whole clusters running. Dead simple, seriously. 3 in the morning, still tired. And from 3,000 miles away, worked the first time. I went back and forth. I said, you know what about a real disaster? I'll have it kill one of my Hyper-V servers. So I reached over with remote desktop and turned off that Hyper-V server, and that thing failed over. Just great. Fantastic. That's when I realized that I had to demonstrate that in a few hours, and my arms aren't 3,000 miles long. So getting them, I fortunately had a neighbor, but anyway.
Had to get that one turned back on.
Yeah, so there's certainly an issue. So the shared storage has to be on boxes other than nodes, as we said. Okay. So iSCSI, let's talk about this. It's the oldest of the three approaches, the most expensive, although not necessarily. There are so many boxes, so many NASI boxes that have stuck in iSCSI. They run like molasses uphill in January with a headwind. But there are devices you can buy to play with iSCSI. And again, it's a network protocol that doesn't mimic actually. It's a network protocol that lets us take the actual SCSI commands and wrap them into IP. And it works wonderfully. I mean, iSCSI has really, Fiber Channel's great, but it ain't cheap. Right. iSCSI made any idiot able to take any Windows box or Linux box and do a little hocus pocus and make a cheap SAN device, iSCSI device, just for playing with. So it's great stuff. It's a standard, which means if you're talking to a SAN, we probably mean iSCSI. And little terminology for those who haven't done the SAN stuff is that the thing that you and I think of as a server, the thing that's going to be providing the data, it's not called an iSCSI server. It's called an iSCSI target. And the client-side software isn't called the client because that would be too easy. It's called an iSCSI initiator. Where this comes from is from hardware. If you recall, with pain, I hate to bring back the pain, but SCSI terminators and cables that can't be more than 6 feet long and all that nonsense. That's where this all comes from. And so the details, a very important step, is so imagine I've got a Hyper-V cluster with 3 nodes. What does that mean I have? 3 whats?
Servers.
What kind? Hyper-V?
Oh, your virtual servers.
Right, exactly. Got 3 of those guys. This is a domain controller somewhere. We don't know where it is, And then we've got this box somewhere. That's going to be our sandbox, okay? So that guy, because it's speaking iSCSI, my 3 nodes are speaking iSCSI. Well, how do they do that? Well, Windows learned how to do it. Like Windows 7 and Server 2008 R2 were the first versions that had iSCSI initiators in them. So they could be clients. And then there was a download you could do for free with 08 R2 that would make it into a target, a server. That was possible to do. So the clients, it's funny to think of Hyper-V servers as clients, but they're clients of iSCSI. So they're running the client software, the initiator software. So we go to the 3 initiators on the 3 Hyper-V boxes, and we say, you connect to that one target. And again, what's our net effect? Sorry to be redundant, but the net effect is that now we're in a situation where each of these machines thinks, oh, I got a new hard drive, and they're all talking to the same hard drive. Once you do that, and it's a little weird because the first time you've done it, you're like, do I have to do this on all? No, you go to just one node, and you say, okay, let's fire that up. It's like I've plugged a new hard drive in. What happens when I open up Disk Manager?
You should see the drive.
Not only that, Disk Manager is going to pop that little box up and say, do you want to initialize it? Exactly. That's if you're a GUI kind of person, okay? And it's see, when you set up the volume, bring it online and initialize as GPT. Got to be GPT. It's not the MBR drives that we're using things. Clusters have always used GUID partition table. And I guess that's where the world's going. I gather that by the time we get to Windows 12 or whatever the next version of Windows, since we're skipping, like going from 8 to 10.
We're just going on the even numbers now?
Maybe, and then multiply by 3s or something like that. Anyway, initialize as GPT. You create a partition, and it's got to be basic, can't be dynamic. And I really wish that there were a little wizard that did this for you, because if you screw around with this, well, let's say for half a week trying to get it to work, if you don't find the web pages that make it easy, this is important stuff to know.
And what's the reason that it can't be dynamic?
Something to do with the software. I'm just guessing here, but I know that when they got started doing this stuff, this is back before there were dynamic drives, and so I'm thinking there's something like that is going on. It may also be that, I'm just making this up, so this could easily be wrong. Bear in mind that we're going to format it, ultimately, spoiler alert, we're going to format it not as NTFS, but as CSVFS. We actually do that. You take NTFS, and you never explicitly format something as CSV, but under the hood, CSV, Cluster Shared Volume, we'll meet later, is essentially a new file system. Okay. Right. So you format it as NTFS, and I don't know if 2016 is going to finally take the wraps off REFS, but I hope they do, because there's some awesome stuff. I'll give you an example of what's cool in REFS. Is that one of the ways, we talked about the metadata. I mentioned it in passing. Metadata on an NTFS volume is the basic block that says this is where it begins, the spare block and the super block. This is the root. There's the storage bitmaps that say what clusters are being taken and what aren't. And the problem is always this. So if I've just taken a cluster and allocated it, that's one bit I've got to change on the storage bitmap. So what's happening? For one brief second, I am rewriting something very, very, very important. What happens if somebody pulls the power cord out? Oh my God, I might have lost the whole volume. What REFS does is it does something called copy on write. Right now, the storage bitmaps are hard-coded to where they have to be. With REFS, they can be anywhere. So what happens is when I want to update the storage bitmap, I write a whole new one someplace else. I'm simplifying. And then I say, ready, go, and I flip the switch. So all I do is change a pointer. You say, wait a minute, Mark, what about when that pointer's being changed? No problem. It's got the one value or the other. You pull a plug on this thing, plug it back in, worst thing that happens, you lost your last change. Right. You never toast a volume. I can't wait. I want it on my phone. So. Drive letters unnecessary. In general, you're going to see with shares as well, don't use drive letters. And that online thing you did, it happens automatically. If you're watching the other nodes, it's kind of cool to go, they just light right up automatically. And so now we've got a shared LUN, and life is good. Make sense?
Yep.
Have you played much with storage spaces?
No.
You really ought to. It's a whole, in your copious spare time, you know, 2 kids, a vice presidency of a company, that sort of thing. But what's neat about it is that you essentially, let's jump ahead a slide. The notion here is that I can take 2 boxes, and this is much simpler than you would in the real world. But I've got some storage, and so that thing in the middle there is called a JBOD. It's called just a bunch of disks. And all it is, it looks like a SAN, but it's a device that can be as little as $500. Don't get the $500 one, but as little as $500. It's hard to spend $3,000 on one of these things. And it's really just got racks and racks and racks of hard drive spaces. Yep. You're going to use SAS drives. They'll take SAS or SATA, but you can't do SATA because SATA can't talk to 2 drives at the same time. I mean, you could do it, but this thing would have to ignore the SATA drives. So you pop in SAS drives in there. And then you've got, so again, there's no brains in this box in the middle. That's the important thing. There's no motherboard, there's no Linux, there's nothing like that. It's just a whole bunch of connectors. There may be a little bit of brains for power management or something like that. And then we have a SAS cable, and that's the same kind of cable that you would use if you were just connecting one SAS drive to your server. Then you've got a SAS adapter sitting on these 2 guys, a classic mini PCI SAS adapter, $500, something like that. Now what's interesting is these SAS adapters have got RAID hard-coded. I mean, 99 out of 100% of the people that are using these things, they're letting the hardware RAID happen. Okay. Storage spaces said, don't do that, I'll do it. And it's got some really interesting alternatives. There's one alternative where you're doing regular old RAID. But they have another one, the one that in many situations makes sense, where you're mirroring, but you're not just mirroring normal, you're doing 3-way mirroring. What that means is you could lose 2 entire drives, and you're still fine. So it's not even like RAID 6. So there's some interesting stuff going on here. And you say, well, why is that good? And the answer is, at this point, Pentiums are really good at dealing with big blocks of data. So when you ask them to do things like the XOR stuff you've got to do in order to do RAID, it's really, the performance on these things is comparable to hardware in many cases. So something worth looking into, and so much cheaper than a SAN, you can't believe it. Right? So, but to return, so this arrived with Server 2012, and it got better with 2012 R2, and it's going to get even better with 2016 or whenever they ship the thing. And so once you get a bunch of drives, you create what's called a storage pool. Remember the picture of the big cloud, the big drive in the cloud?
Yep.
That's the storage pool. So I've got how many drives? You don't know, you don't care, because it's handling all the USWAP drives, and there's no problem kind of stuff going on. You then carve out pieces of it. Microsoft didn't call them LUNs, but what the SAN guys would they call them virtual disks, because that wasn't an over.
Same general concept, though.
Yeah, exactly. And you create volumes in the drives. And in this case, what's nice about it, though, is that, once again, if we look at our picture here, then both of these guys are doing storage. HV1 and HV2 are doing storage spaces. I would not do that here. I'm building the cluster and the Hyper-V nodes at the same time, but you could do it. You probably want a couple levels, and we're going to look at a picture of that later. Making sense?
Yep.
Cool. The best part one is SMB. Hyper-V 2012 Plus allows file servers to act as shared storage. I tell you, this is even before the thing shipped. I was sitting in the courtyard just off campus from Microsoft and built one of these things from 3,000 miles away, and it worked just absolutely wonderfully. It's that same old net use stuff you've known. Do you know how long we've been doing net use?
No.
First version of that stuff appeared in the IBM PC LAN support program. First version of MSNet, released on, if I remember correctly, the 15th of April, 1985, which means we're talking in last day of February
2015.
So in a couple of months, Microsoft networking will be, what, 30 years old? Yeah, net use has been around that long. So you can store configuration and VHD files on a regular old SMB. I say SMB3. It'll actually work with the old SMB. SMB3 is a change to the file server service that appeared in 2012. They completely revamped it, it was all about speed. I'm going to show you a picture in about 60 slides where we'll see how this all comes together. They let you build a new kind of server called a scale-out file server that we're going to meet a little later. Why is it good? An idiot like me can do this without even thinking. Straightforward. So cheaper than a SAN, easy configuration, and if you take the time to build, not just a share, but a scale-out file server cluster share, you have transparent failover. 0 millisecond change time.
And I mean, this is perfect for anyone following at home, because I mean, you can go dig up any old server basically and
exactly. Well, building a scale-out file server for application data would be a little more work. You probably need about 3 machines there. But yes, if you want to just try your first Hyper-V,
yep.
I'm telling you, my first Hyper-V, my share was just my 2003 file server that I still had running at the time. And that's some free space. Well, I would still be running it, but it's a steam-driven. You can't get the coal anymore because of the EPA regulations. It's just a mess, All right, some rules on how to do it, though. Okay, you create the share, all right? Now the permissions get weird. The machine accounts of the nodes. So if I got machines named old and new, or HV1, HV2, HV3, those are the guys that are going to get full control of the share. That's a little odd. You remember how there's a name in the cluster? Well, that guy too. So if we had HV1 and HV2, that's 2 nodes, in a cluster called whack whack cluster, those 3 accounts would have full control of that share. And that's all you got to do.
Are there any security concerns that come into play there?
It's a good question, but the thing is, it's a really good question. But if you think about it, if we're going to build a Hyper-V cluster, I'm going to come out to the Chicago office of Pluralsight and build you guys a Hyper-V cluster. What are you going to do? You've got a room where the file server's here, Hyper-V1's here, Hyper-V2's here. They're sitting on a subnet that doesn't talk to the internet, more than likely. I mean, that communication.
Hopefully.
Well, I mean, obviously the servers have to be able to get off the internet on another channel. But the point is that it's intra-data center security. I'm not saying that's nothing to worry about, but it's a whole lot easier. Okay. Remember, any of these IP connections, I've never done it, but you could certainly IPsec any of them. I don't know that I'd want to do that. I'd be introducing overhead, and I don't know if it gets in the way of the software. But
I don't.
So we got the nodes, the identical nodes. We got the shared storage in many different ways. Now it's time to build the cluster. Things get a bit easier. Now, as I said, believe it or not, if you were building these things in 98 or 2003 or 2005, you'd hope that you had all the right hardware, but you didn't always know. And so now they've got a nice wizard that helps you out. It'll just let you test the thing out. So it first does a basic, will this work with the hardware check? And it's a huge HTML report that says, well, yeah, this hardware will work, but if you did this, it would be better, et cetera, et cetera, et cetera. You then have to give the cluster a name and a machine account and give it an IP address. And in my examples here, my screenshots are of a 2-node Hyper-V cluster. Just to point out, you'll see old.apple-orchard.net, new-apple-orchard.net. Obviously, the Active Directory is named apple-orchard.net. That's for some of my screenshots, and I created a thing called VM Cluster 1. I want to point out, though, to everybody that when I'm doing a graphic about how something's built, I'm just calling them HV1 and HV2 and HV3.
Are there best practices for naming conventions? Specifically with clusters?
Yeah, I'm sure there probably are within large Hyper-Vs, but bear in mind, I'm guessing 98 or 99% of the clusters out there are just 2 nodes. It's probably 2 Hyper-V boxes, some kind of shared storage, and that's it. But that's a good question. I think people should probably think about that before they get started, but I just don't know of that many people that are building even 4 or 8 node Hyper-V clusters.
So maybe to a certain extent, just keeping the best practices that you've already implemented in the rest of your naming conventions.
Well, change control. I mean, just so everybody knows. I mean, clearly you would want all that stuff because you're going to the trouble of building a cluster because of reliability. And if you've got to spend 20 minutes figuring out what IP address is on which node, then you're kind of defeating that, right? So we test the cluster, and the failover cluster manager will validate a cluster. It has an option to validate it, so it's checking it. You just choose the hyperlink that says validate configuration. It then says what machines go in there. It thinks about it for a while and gives you an HTML report. I won't even put a screenshot. It's just so basic. Or better yet, PowerShell. Test-cluster. People say PowerShell is hard. You know that failover cluster manager, that's click, 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 click to get it done. How about this one? Test-cluster, new, comma, old, dash report, C:\r file. That's going to create a report called C:\r file.mht. Yeah, the PowerShell's difficult stuff. I understand why not everybody's doing it. Now to create the cluster, we can either use the GUI or PowerShell. Same ingredients. Names of the nodes, what to call a new cluster, and we need an IP address. PowerShell, new dash cluster, dash node, and there's the list of your nodes, dash name, VM cluster 1, dash static address, and there's the IP address. That does look difficult though. Probably, we should go to the wizard, huh? So the wizard starts out, and there's a rule with wizards. The first page is useless. It's the first page useless. Now, the heavy little checkboxes don't show this to me again, but I want to say I never wanted to see it in the first place. If there were just a group policy that said, don't show me the useless page on a wizard, that'd be awesome. And then I list the nodes. And here it's going to be new-apple.orchard.net and old-appleorchard.net. Just a reminder, who's not a node? We've got that sandbox. We don't name that guy. We've got a domain controller somewhere. We don't name that guy. And remember, a domain controller could not be if you try, this wizard will say, that's not good, that's bad.
Will PowerShell error out if you try to add a domain controller?
PowerShell will actually reach out and slap you in the face. little PowerShell head comes right out. Says, you dummy, go back to the GUI. You seem like a GUI guy. Exactly, that's right. So the next question is access point, and this is the page, this is the important page, because what's it asking for? It's asking for a cluster name, and it wants to know an IP address. And notice it's even telling me what subnet it expects it in, because typically we're going to keep, as I said, a cluster within a particular subnet. And then if I fill those values in, we're going to call it VM cluster 1, and it's got some IP address there. Then there's a page here. It says, are you sure? Good to have these confirmation pages, because you're probably like me. It's a Friday night, and nothing to do. So I'm just sitting by the server, me and a bottle of tequila, just typing random stuff. And if this hadn't stopped me, I might have a cluster. So it's good that we got that. It thinks about it for a while, and the result is our friend, the failover cluster manager. And this is actually the same screenshot you've already seen, but it populates and tells you the names, etc. Make sense? So we have, my friend, a cluster. Oh, sidebar. If you ever, and you will, if you ever want to unmake a cluster, because I don't know about you, but I can never do anything right the first time. I mean, seriously, I follow the instructions, it doesn't work the first time. I don't know why. I've stopped calling Microsoft. I just format every system. I flatten the systems, I start over. It works the second time. I don't know why. So the funny thing is you use the failover cluster manager, and the funny thing is it doesn't say unmake the cluster or delete or remove. It's destroy. It destroys, it destroys the cluster. It doesn't do the whole job, though. This is the important thing. What happens is, remember, it's created a machine account in the name of the cluster. Mm-hmm. It doesn't take it out. You start getting all these error messages about how Kerberos can't talk to it and blah, 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 blah. And the server manager GUI, think about it, the server manager GUI, when you have more than one server, it wants to keep them all, like talk to them on a regular basis. You're getting errors at the gazoo. So you have to go into the server manager GUI and say, get rid of that machine, and you've got to remove the AD account as well. Make sense?
Yep.
Because if you don't do that, it's going to drive you crazy.
Any idea why they don't have the removing of that account in the actual destroying of the cluster?
I'm assuming that real men or women don't administer from the server manager, and no one. Remember the value of server manager for 2012. Its job is to be such a bad GUI that you want to learn PowerShell. Their hearts were in the right place when they created it. I don't know. Sometimes there's that question of does anybody use this stuff? You know?
I was just wondering if there was any reason that AD account should stick around.
No, there isn't. I'm just going to offer a guess. they really want you to buy System Center. The idea that I'm talking about Hyper-V and I haven't talked about STVM, and Microsoft Ninjas will appear in the hall once I'm out of here. So it may be that if you're using VMM, it's easier. That's a possibility. I'm just guessing.
Okay.
Now, one odd thing is that if you're using the storage spaces, it needs to be introduced. I get this wrong. I haven't done this in a while. It needs to be introduced to cluster. The share does not need to be introduced to the cluster because it doesn't care, but the iSCSI does. Now, there's a checkbox, you probably didn't notice it, that said automatically add all available storage. And that will usually introduce our iSCSI LUN, assuming you're using an iSCSI LUN, it will usually introduce that to the cluster. But if it doesn't, it's an extra step. You look troubled.
No.
Okay. And so we've clustered several servers of the same type. They're all connected to shared storage. So we've already got the initiators talking to the target. And that's where the SQL database is going, that's where the Hyper-V is going, et cetera. But if it's, you may have to take an extra step. And what it looks like is with PowerShell, you use get-cluster available storage. And that says, what does the cluster know out about there, but hasn't connected to? Looks like that. Get-cluster available storage, and then I pipe that into add-cluster disk. And add-cluster disk, that's the thing that says, introduce it to the cluster, make it part of the family.
Now, in that case, like if you have two SMB shares, would you be adding two in that version?
Good question. Again, SMB shares don't need to have this happen.
Okay.
There is. No. I may be missing something, but whenever I do stuff with SMB shares, I don't have to worry much about that. Although the fact is that if I guess that's really not true anyway. Yeah, I mean, if you're doing SMB, it's a lot easier, to tell you the truth. Okay. Or alternatively, if you know the disk number that you want to introduce, get-disk2, pipe that into add-cluster disk. That's nice and straightforward, easy stuff. In the GUI, alternatively, we're back to the Failover Cluster Manager. If we right-click disks, it's going to go out and it's going to look to see if there's any storage out there that it knows about. And here it's telling me that, oh yes, there's indeed some cluster disk there, and that's where it's sitting, and I can surely connect that. And when you click OK, at that point you're all connected. And by the way, if you want to find out about that, you can just say get-cluster resource. And that will show you networks and shared storage and all that kind of stuff.
Cool.
What's time now to fight corruption? So we've got our cluster and everything. We haven't really put anything on it yet, but we want to make sure that we're never in a situation where the two nodes are stepping on each other. Okay? And that leads us to a discussion of this stuff. It's all about the prime directive. It's something called quorum. So we've seen there's a couple of machines and they store data in a fashion that is, as I've said, vulnerable many times. Okay? How do we keep this from happening? So some background here is, first of all, how does this work? How does failover work? If you're a Hyper-V server and I'm a Hyper-V server, and we've got some VHDs sitting on some shared storage, if it's passive active, maybe I'm doing all the work and you're doing nothing. How do you know that I'm dead? How do you know it's time to step up? Well, we know it's send each other something called a heartbeat. And they send this heartbeat once every second. So I say, Gary, I'm still good. And you better send me a message every second that says, Mark, I'm still good. All right? If I don't hear 5 in a row, I assume you're dead. So 5 seconds of no talk is enough. So what happens in that situation is, if I'm doing all the work, and I'm going heartbeat, 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 and you're
not responding,
then you say, oh, Mark must be dead. At that point, you reach over to the LUN, or whatever it is, it's got the VHDs on it, and you pick those servers up, and you start them up. Now, what's probably going to happen in a situation like that is that all of those servers have essentially been shut down. You're going to scoop them up and start them up again, but you're doing it automatically, and certainly you'll have things up and running within a minute or two. So this is our basic active-passive, not what we're going to end up with, but that is the very simplest kind of Hyper-V cluster that we can imagine, and that's what we had prior to 2008 R2. Still not a bad answer, reasonably priced, et cetera. Making sense so far?
Yep.
All right, then, good. So, and that's called failing over. That this idea that it happens automatically, everything is wonderful. So if I don't hear your heartbeat for 5 seconds, I'm going to spring into action. So those communications are important. Now think back to 1998. We are running 10 megabit Ethernets at this point and moving lots of data around. And we've got machines that are running at, maybe, 4 megahertz or something like that. No, not 4 megahertz. More like 50 megahertz, something like that. The original Pentiums were 50 and 56 megahertz, right? So I mean, not terribly fast at all. And so if we used our one, 10 base 2 with the terminators on the side, Ethernet tap things, and we're pumping data across those wires, we're not that fast to begin with. The network's not that fast to begin with. 5 seconds, we could have 5 seconds of silence and an unnecessary failover.
Yeah.
So the original idea was you had to put a separate NIC on each of these machines. So the simplest cluster arrangement, if we're doing this in 2007, the simplest cluster arrangement is, we got wires to talk to that SAN, but we needed a separate set of NIC just for you and me talking, which is not a terrible thing, but it certainly added some extra cost. And an awful lot of people would put more than one of them, 2008, in contrast, says you can pump the heartbeat over the main line, because we're talking about gigabit or 10 gigabit or maybe 40 gigabit stuff. Some people use multiple heartbeat NICs, so it's a matter of how much belt and suspenders you want to put into it. It's all about the reliability. There is a sexy word for that, though. Now that we do everything over a single NIC, it's called converged cluster networking, which, more NICs would be better, but then we wouldn't be converged. So, as I said,
No, the case though, if you have a NIC that is dedicated to the heartbeat, if that NIC goes bad, it thinks you're dead.
The NIC goes bad, the cable falls out, the switch, any of those things. No, clearly, if it's 2002 and we've been tasked with getting a failover cluster working, I forget what a 100 gigabit NIC would have, ISA NIC would have cost in those days. I forget if we were still doing ISA at that point, but certainly a decent investment. If we're spending all this money for multiple servers and SANs and things like that, what's another $500 for some switches and so no, it definitely makes sense. There's another cool thing that's happened around 2008 and later is that, well, actually earlier than that in 2000, is that if you think about it, if we want to do converged networking, but we want to be sure, we can always use QoS. So the whole quality of service stuff, you can actually say that heartbeat service thing gets priority, gets 10% of the bandwidth or something like that. And it's one of the reasons why 2008 blessed the idea of converging the networks. So some more details here. So I say I'm not quite dead yet. What might that mean? Well, what if there's just two of us, HV1, HV2, and you're not getting my heartbeat because we only have one cable and the NIC fell out. The cable fell out or something. So if HV1 thinks HV2 is dead, what's going to happen? Well, if HV2 thinks HV1 is dead, what's going to happen is that HV2 is going to say, oh, HV1's dead. I got to go grab those files. HV1 doesn't know that HV2 can't hear the heartbeat, and so he says, well, I'm still on these files. So now you're grabbing the same files that I am, and that's going to be the beginning of a bad day at the office. That's called a split brain cluster. And the answer for that almost certainly leads to corrupted shared storage. And so that's where quorum comes from.
Okay.
So originally quorum was going to be pretty easy, pretty straightforward. The notion is, again, clusters equals reliability, just to review. Clusters need shared storage. Confusion is bad. So quorum is just extra overhead. It doesn't make it faster. What quorum does is the quorum says, we're going to do some extra things to, when you think failover is a good idea, you have some double check information to make you pretty much 100% sure that you're not going to be stepping on me or I'm not going to be stepping on you. That's the idea. It's a method where each node can check that it might be in a position to corrupt the data. This is where the prime directive comes in. Would you rather have the cluster go down and you not corrupt the data, or do you want the cluster always up, but there's the small chance that we might corrupt all the data?
Let it go down.
That's what this is all about, exactly. So if any given node doesn't have quorum, and what's quorum? Quorum is, the easy part is like we see in meetings. If there's 5 people in the room, or I don't know, what do we need? If there's 5 members and we need quorum to have a meeting, we have to have at least 3 people in the room. So there's a number of different quorums. So the most basic one's called the majority node quorum. If you have an odd number of nodes, this works wonderfully. I got to hear a majority of heartbeats. If there's 3 of us, I got to hear 2 heartbeats. If I can't hear 2 heartbeats, I'm stepping out. Yeah. We could demonstrate this with another astounding animation. So we got HV1, HV2, HV3. HV1 hears 3. I hear my own heartbeat. I hear HV2, HV3. 3 is certainly a quorum of 3. I'm good. HV2, hear 3 heartbeats. I'm happy. HV3, hear 3 heartbeats. I'm happy. But what happens if HV3's cable falls out? It doesn't know, or something's happening, something's denial of servicing it, or something like that. Well, HV1 doesn't hear HV3. He hears 2. Says, okay, hear me, and I hear 2, so we're good. All right, I'm still in. HV2 says, I hear HV1, hear myself, we're good. HV3 says, I only hear me, so I know I'm alive, but maybe I should stop doing what I'm doing. And it steps out at that point. Making sense?
Yep.
This is super easy to explain, but largely useless. Because 99% of the clusters out there are 2-node clusters. And clearly we can't use a majority there.
Right.
So what we do at that point, when the heartbeat fails, I got one, you got one, you don't know if I'm still around. So the answer is a tiebreaker called a witness. Okay? And there's lots of kinds of doing witnesses. One kind of witness is to create an SMB share that we can both see. Another one is a LUN that we can both see. And I don't have it here in the PowerPoint, but Microsoft just introduced something whereby if you're creating a geo cluster, you've got a chunk of your machines in Salt Lake and a chunk of your machines in Chicago, and they're acting as one cluster, then if one city goes down, well, which one's really there? Azure can act as a witness. So both cities can see this Azure witness.
And now these SMB and iSCSI loans, these cannot be part of the shared storage. These are completely separate from the cluster.
They could absolutely be part of the shared storage. Sure. Well, if you think about it, if the shared storage goes down, I mean, presumably, I haven't talked about the details of the shared storage, but clearly the shared storage may have lots of redundant things in it. If you're going to go buy yourself an HP left hand because you want to be absolutely certain, you're going to buy 2 of them and pay for the LUN replication, and you'll be out of business at that point. But I mean, there'll be some way to make sure that you've got redundancy there. And if that's the case, what the hell? The share doesn't have to be big. There's almost no data going on there. If you build that LUN, it's 1 gigabyte. Okay. And Microsoft says, don't back it up under any circumstances. And so, no, if you've got some good shared storage you're happy with and you can carve out a piece of it just for witnesses, go for it.
Okay.
Go for it, yeah. So if a node's unsure, here's what it does. Reaches out to the witness and locks it. So you can't hear me, you can't hear me, I can't hear you. We're like, uh-oh, time to go to condition red, lock. In other words, it's a race. So if you get to that, or if I try to lock it and I see you've locked it, I'm like, all right, he's okay, I have to step out now. Okay. And so that's the beauty of it there. The loser node just steps out of the queue, and eventually the admin figures out there's a problem. See? So our next question is, can I get a witness? So how do I do this? To create it, it's also known as a witness quorum. That's the techie word for it. Create a share, not a node not on any node for the witness. Shared storage is great. SMB share, I've done it with SMB1 shares. It's really just a file share, that's all. Again, machine accounts of the nodes and of the cluster should have full control. Okay. Or build a 1 gigabyte iSCSI LUN and attach it. That's called a witness disk. So we have witness shares and witness disks. Microsoft says that the witness disk is actually better because you and I can scribble notes to each other on the witness disk. Okay. So now we're ready to configure the quorum. Now right out of the box, what do we get? We get it's node majority, which is kind of silly because we only have 2 systems here, so it's not clear. You'd think there'd be big red flaring boxes saying, you want to do witness now or something like that? You know? But if you need a witness, you set one up with Google your PowerShell, and we can use the file cluster manager, and let's see how this works. So we use either the share, the witness share, or the witness disk. And for example, set dash cluster quorum, dash cluster, my clusters, that's the name of the cluster, like VM cluster or something, dash node and file share majority, and then whack server 1, whack witness. I happen to call that share witness. You don't have to call it that. Okay. Or we could go with the GUI. The GUI hides it. You pretty much have to go to like properties, and under that there's more actions. And then you drill down and there's configure cluster quorum settings. You definitely will not find this one Friday night if you've had tequila. This is a safe one for Friday night tequila administration. So then it says, what are we going to do here? And here I'm going to change the nature of we're not going to do it unless we have to. And then we'll configure a file share witness. Again, I'm just doing this because I'm lazy in my example. In actual fact, be a little less lazy and use the LUN. Use it in iSCSI if you got it. Okay. If we're going to do that, it then wants to know what is the UNC path for that. You notice here it says backslash HV1. That's only because I was building something and HV1 was an actual. That's not a node in this particular example. Okay. I need to reshoot that screenshot. So again, UNC path, not drive letter. Don't be mapping these drives to letters. So it then says, are you sure you want to do it? And you say, I have been waiting for a witness quorum for so very, very long. I feel validated. It then goes out and it gives you a little report, and double checks that stuff, and the change should then be reflected in the file cluster manager failover cluster manager, because up top, if you look over, then it's going to say quorum configuration, and it now says node and file majority witness. So the question is, do we add a witness or do we not? Well, the funny thing is, there's a great blog on this that I wish I had the URL handy, but an MVP, as a clustering MVP, he wrote about a 5-page blog about the history of witnesses. It'd be fun to do, but we don't have time. But for the longest time, all kinds of different things came around. But 2012 changed things by creating something called a dynamic witness. See, here's the problem, right, is that if you've got an odd number, 2012 or 2008 R2, if you've got an odd number, you don't really need a witness. Right. But some folks will set one up anyway. Well, now you got a single point of failure, because if the witness stops working. So the best practice was only, in 2012, as recent as that, best practice was only use a witness with an even number of nodes. But you're like, well, wait a minute. If I've got an odd number and one of them goes, I've got 7 guys, one's dead, I got 6. Well, now I'm even number. I need that witness. Well, 2012 R2 gave us a dynamic witness. It says always have a witness called a dynamic witness. The witness turns itself off when there's an odd number, turns itself on when there's an even number, which is pretty cool.
Okay, so now just even if it's only a 2-node, you just go ahead and get it set up. Or sorry, if it's a 3-node, you just go ahead and get it set up right away.
Absolutely, absolutely. That's assuming you're going to, upgrade your existing Hyper-V cluster to 2012 R2.
I'm saying we're starting new.
No, exactly. There we go. Using our MSDN accounts that we get from being MVPs, right? So where have we gotten? We got our nodes. We got our shared storage. We now can sleep easier at night, knowing that the prime directive is, being exercised and enforced. But there's still that performance question. Let's talk about that. So most clusters, until 2008 R2, every cluster is active passive. So if you were to say to me in 2008 days, well, we finally got Hyper-V, it's pretty awesome. Let's build a 4-node Hyper-V. What did you just do? You told me to buy 4 top-class Hyper-V servers, and 3 of them are going to do what?
Sitting around.
Heat in the room. Heat in the room. That's just all they do. They just heat the room. So, and nobody's going to do that. I mean, really, nobody's going to do that. I'll show you a workaround that's just insanely complicated that people did, but no one did it. What if we took those same 4 machines and put Hyper-V on them? I should put VMware on them. We'd be smoking. So, you needed an answer. So, thus far, we have created active-passive. And understand that when I say active-passive went away, it only went away in 2 special cases. If you create a DHCP cluster right now using 2012 R2 software, that is active-passive. So active-passive is still the majority of things you can cluster are still active-passive, not active-active. So let's step back a moment and talk about what these things mean, okay? It's important because it only applies to Hyper-V and SQL. Okay. But those are big. Those are the important work. Well, and scale-out file server. So here's my little story here. This is before. So if we're talking about Server 2008, Hyper-V, and we want to build a cluster, we have some shared storage. Let's just say that's a LUN. Okay, we don't even have storage spaces yet. So I've got 2 machines. Notice I've got my guy on the left there, HV1, that's my hot pig server. And then I've got my Bluebell Blue server over on the right there. And I've got 4 VHDs, just to make sure everybody's on track here. Every virtual machine needs a virtual hard drive, at least, just as every real computer needs a hard drive. I'm going to simplify for the purposes of these examples and just say that 1 VHD equals 1 virtual server. Okay. It's just easier that way. So if in our cluster we have 4 virtual servers, one's a web server, maybe one's doing CRM or something like that, they all do important things, and we really want them to stay up. Here's what I do. They've each got a VHD, so there's only 4, this LUN has only 4 drives. I'm simplifying. There's actually configuration files, but let's just say there's 4 files in that shared storage. Okay, great. HV1, notice the colors. HV1 is doing all the work. What's HV2 doing?
Sitting around heating.
Twiddling its e-thumbs, exactly. I mean, and we can play games about putting workloads on it and all that sort of stuff, but it's a lot of Mickey Mouse stuff, and it just, when we compare it to VMware ESX at this point, then we're going to say this is ridiculous, we're not going to do it. So 4 VHDs shared are the bases, only 1 machine's doing all the work. So we've got an active node, that's our pink guy, and we've got a passive node, that's our blue guy. So active passive once known as shared nothing. Why are we doing it? Well, their heart's in the right place. We fear corruption. We're absolutely certain. We're absolutely not certain. Every LUN does all the work. Passive node only moves when it detects the active is dead, then it grabs the whole LUN. And only one's doing any work. So it's troublesome. Plus is it's well understood. We know it's going to work. Simple and safe, right? And the workaround, this is the workaround people would have, is they'd say, well, instead of having one big LUN, I'm going to make my SAN guy carve up 4 different LUNs. Now, this is like in 2008. SAN tools were not as easy as they are now. And this is a good way to have the storage guy put a contract out on your life. So the notion would be, we take our nice big LUN and we cut it into 4 separate LUNs, 1 for each VHD. So now, what does that mean? It means it's now possible for me to say, well, because I've got 4 LUNs, I'm setting up 4 clusters, essentially. Mm-hmm. All right? And so then I could set it up so that HV1 handles VHDs 1 and 4, and HV2 handles VHDs 2 and 3, and this is going to be a mess. Plus, I'll be dead because the storage guy put a contract out of my life. But it is an answer, okay? So in other words, we end up with HV1 being active for some and passive for others, and so on. That's not a good answer. A better answer would be, we'd love to have a LUN shared by more than one Hyper-V system. It'd be awesome if I could have one big chunk of storage so the SAN guy doesn't kill me. Both of them simultaneously safely reading and writing the same LUN. A little redundant here, but I want to clarify our goals, what it is we're trying to get done, and without corrupting the shared storage. In 2008, R2 appeared with something called a cluster shared volume, or CSV. And people always correct me when I say this, but I say it's a new file system. They say, no, it's not a file system. It is. Look at the UI, and the UI refers to those volumes as being CSVFS. So the changes to Hyper-V server to understand these guys, that was a big, big change. So 2008 R2 does 2 things. First of all, it introduces the idea of CSVs. Second, Hyper-V understands it, and the clustering software understands it. Big stuff. Still expensive because you've got to buy the enterprise version, and they haven't helped us on the SAN stuff, so we're probably going out and buying a SAN. So this was interesting, but it wasn't,
it wasn't there yet.
It wasn't, yeah, exactly. It wasn't killing the world there. And then you end up with something like this. So now I've got my HV1 and HV2, and now we have our 4 files. You notice that I've colored VHD 1 and 4 to be the same color as HV1, and VHDs 2 and 3, same color as HV2. So now what's happening? What's happening is that HV1's active on a couple of the VHDs, HV2 is active on the other ones. They're both active nodes. They're kind of passive and they're kind of active. Sort of passive-aggressive nodes or something like that.
So in this situation, you need to make sure, though, that the load of HV1 can actually handle all 4 virtual machines.
Absolutely. When you're buying both of those machines, you're right. So you're making the point that it's still not perfect because I'm going out and buying for you HV1, which is twice as powerful as it's going to be most of the time, because there needs to be those moments when it can do it all. Right. Make sense? Mm-hmm. It's a reasonable thing to say, Gary, but on the other hand, how many times are we going to be down? Could we live with a world where for an hour and a half while I'm trying to figure out what the hell happened to HV2, that everything's running at half speed? Again, it's the beauty of clusters. You're the boss, I'm going to say, how much you want to spend, boss? I know I can keep things up. May run like molasses uphill in January with a headwind, but I can keep things up. Okay? And the greater beauty is that then maybe we start talking about, maybe we should get a 3rd node. Because 3 nodes that are all underpowered if they had to do all the work, right? That's the cool thing. Although honestly, if we did that, if we had 3 nodes or 4 nodes, if one of these guys goes out, there isn't anything that automatically balances it particularly well. It doesn't really rebalance. You have to get it to 2012 and scale out file servers in order for that to happen automatically. Okay. So that's 2008 R2. CSVs come in, and we get support for Hyper-V, but nothing else. 2012 gives us CSV support for SQL. Clustering support goes from enterprise to standard. Now things start getting cheap. We get storage spaces, and we have support for CSVs on a scale-out file server for application data. This is exciting. This is a new kind of cluster. It looks like this. This is the single most important slide in our presentation. So let's just take a minute and bust this sucker apart. At the bottom, we have 2 Hyper-V servers, HV1 and HV2. They ultimately want to talk to a VHD. Up in the upper right-hand corner, I've got VHDX, that little cylinder there, and imagine a simple world where we're just doing one of them. But I mean, And the notion is they don't know what it's sitting on. As far as they're concerned, each of them can touch VHDX at the same time. Nice. Let's bust open that cluster and see what's in there. There's different ways to do this. But in this simple situation, I could have a case where I've got something in the middle here. Maybe it's a SEN, maybe it's a JBOD box, we're doing storage spaces, whatever. Okay? But the point is, I have 2 file servers. Now, what would these 2 file servers normally be doing? As we've said many times, one's doing something, the other's doing nothing at all. With a scale-out file server, though, they're both talking to the same files. They're both capable of looking at the same files. That's A. B is, because I'm serving up a file, if I'm a file server, if I'm a Hyper-V server and I die, you pull a plug. How much have I lost? A lot. Because if I'm hosting a virtual machine and that virtual machine has 16 gigs of RAM, 16 gigs of my real RAM is the actual only knowledge we have of what was going on in that server. Transferring that over to my friend, if you're HV2, we need big pipes. What about a file server, though? At any instant in time, how much, I don't know, changing every moment. How much transient data am I thinking of? Not much. So that means I can constantly talk to you about it. That's why, if you got SMB3 clients, that is 2012 or 2012 R2 Hyper-V servers, and all these other guys running 2012 or later, that if I die, you really can pick up in midstream for me. That's why the failover. But again, everybody's got to be SMB3, which is easy enough to do. Okay? So that's the first part, right? What's the next part? How are we doing this? We're doing this with SMB. We said, now wait a minute, Mark, SMB is not very fast. SMB3 is lean, mean fighting machine for this. Also, how do we connect those Hyper-V servers down there on the bottom to the scale-out file servers? Well, we're not using NICs. We're using RDMA boards. There's these things, remote direct memory access boards. And typically what their job is, it's like a NIC that can't be routed and that runs short distances. Way back in the late Pleistocene, when we wanted to move data from one computer to another before there were networks, we'd get a printer cable and put it between the two of them, run a program called LapLink that would allow us to run data way faster than we ought to be able to do it. And why? We got away with it because we knew the cable was short. Same thing here. You can buy for a very reasonable price these RDMA boards at 56 gigabits per second. That's not, but wait, there's more. You can also plug more than one of these in. And if you're plugging 2 or 3 of them in there, SMB3 says multiple channels, and it binds them together automatically. SMB multi-channel, which means, I don't know if you saw, remember Build in 2011, when Satya did his keynote, it's the first time they showed it to us, he had 3 of these 56 gigabit per second RDMA boards for some cluster. He was doing some SQL stuff, and I don't know, there was 168 gigabits per second or something insane like that. I mean, it was so fast that it knew the data before it actually, went back in time, So this is what Microsoft's doing. They're saying these RDMA boards, sure, they're not cheap, but compared to a 40 gigabit per second Ethernet card, they're A, faster, and B, cheaper. Yep. And C, the software is tightly bound to the stuff, understand how it all works, and they may have come out with something faster than 56 gigabits. It's coming out. I don't know if it's out yet. So you're going to see the stuff getting faster and faster. It's just for short distances inside a data center. But even a medium-sized company can afford this kind of stuff. You build this, and some of the performance that we're seeing is fantastic. And by the way, interestingly enough, we talked about the different kinds of performance stuff. And if I recall correctly, is this right? RAID was not optimal. It was the mirroring, or I may have it backwards. I have to talk to my friend Karsten. He's the smartest guy I know about setting all that stuff up. So this is kind of neat. I think of this as the missile. This is the missile. It's the lower booster and then the payload that goes after VMware. So more details. So I've kind of waved my hands about how we keep you from clobbering one of my VHDs. It's real simple. We just make us a little smarter. You do VHD 1 and 2, I do VHD 3 and 4. And if we never resize them, you're never going to step on me. Isn't that cool? Doesn't it make sense? So the idea is HV1 says, don't touch my files, HV2. HV2 says the same thing, HV1. We never clobber each other, right? Okay, turn the lights off. All right, in actual fact, there's this one case we could do that. All that NTFS metadata. There's still, every time you open a file, every time you close a file, every time you make a file bigger, smaller, create, delete a file, you update the NTFS metadata. Okay, the good news is what? If there's only 4 files there, and when you're building when you're building a virtual machine, you tend to figure out how big the VHD should be, and you lock them in. Right. So the space has already been taken. So that's an easier task. But we still have to worry about the NTFS metadata. So what cluster shared volumes do is that nodes each own their own files, but the metadata is owned by one of the nodes. So if I've got 4 Hyper-V boxes, one of those guys becomes the metadata coordinator. He becomes he's the manager. Sometimes it's called, it orchestrates rights to the metadata. What's the bad news? The bad news is that machine becomes a bottleneck. Now, if we are 4 Hyper-V nodes, and we're looking after 80 virtual servers, it's still not an awful lot of work. We're not opening and closing stuff a lot. So that means that, what's another example? SQL. SQL is a case where we have a small number of large files. Yep. Hyper-V, small number of large files. Well, it'd be a really bad example, putting home directories on this thing, because you've got zillions and zillions and zillions of files. Would it work? I'm not sure it works the verb, but yeah, it's just, it would
functionally
work.
It would work.
Yes,
performance-wise.
You wouldn't like it at all, not at all, So with that in mind, let's see how to create a CSV. So we got a shared storage space, you do CSVs on that, or an iSCSI LUN hooked up to the cluster. With a share, you don't have to do that. So like if you had the scale-out file server for application data, then that stuff's all happening for you, okay? Again, I'm simplifying on some of this stuff because there's more details. You just right-click it in the Failover Cluster Manager and choose Add to Cluster Share Volumes. Or PowerShell is real easy. You say Add-Cluster Shared Volume and the name of the disk. So if I said Add-Cluster Shared Volume, Cluster Disk 1. Now if you want to know what those guys are, you say Get-Cluster Resource. And so I could have something along those lines. This is this is a screenshot where I first attach something. So I'm using Get-Cluster Available Disk. That will tell me what's available out there. And then I say Add-Cluster Shared Volume, and then that disk, and it comes back and shows me. And I can always say Get-Cluster Resource to find these things out. From the GUI, it's not bad. Within the Failover Cluster Manager, it shows you all the storage that it knows about. You right-click, and you're going to say Add to Cluster Shared Volumes. It thinks about it for a minute, it becomes a cluster shared volume. It then appears in Explorer like this. If you click on that in the Failover Cluster Manager, it will show you that every one of your nodes has a folder called cluster storage. So everybody thinks they own the same folders. So if you think about it, it's taking the whole file cluster thing a step further.